Hi, my name is David Bañuelas, and I'm really interested in seeing how much carbon can be stored in our local salt marsh. Well, I'm particularly interested in our local salt marshes because, and within the next 100 years, sea level rise will basically drown our salt marshes. And salt marshes are an important source of blue carbon, and salt marshes store a large amount of carbon. And one of the reasons that we want to know why salt marshes will be impacted by sea level rise is because marine bacteria actually respire carbon. So the first thing we want to do in our research is actually account for how much marine bacteria is going to release carbon, and then how much salt marsh vegetation we need to preserve in the next century to actually store that carbon, and not just to break even, but we actually want to have a surplus of carbon to fight climate change. One of the ways that we can save salt marshes is through a process called artificial accretion. And actually, we can add sediments to the salt marshes within the next 100 years, so they actually keep pace with sea level rise. However, we don't know exactly how much or at what times in the next decades that we need to apply the artificial accretion. So our research is actually going to create tools for land managers and agencies to actually calculate that, and then also account for how much carbon will be respired by marine bacteria and our salt marsh estuary system. And that'll actually give us a good picture of what interventions we need to take to save the salt marsh.